Welcome to another episode of the True Facts series, where we uncover the mysteries hidden beneath the deep sea. The story begins with a mysterious case from 15 years ago, in 2008. An internet user who called himself Peter uploaded a strange video. The footage showed what appeared to be a squid resembling an alien creature, spotted at a depth of 7,800 feet beneath the sea. The squid's flesh was swaying, and its body was facing directly toward the camera. Where its body should have tapered off, there instead extended several long, thin tentacles. When the camera looked downward, the tentacles seemed to descend endlessly into the deep. Focusing closer on them, it was discovered that the tentacles bent at sharp 90-degree angles, something completely unlike known soft-bodied marine animals. They looked more like humanoid arms, with elbows and joints. Was the video real? How large was this creature? The footage quickly sparked online debate and prompted expert investigations. Soon after, Shell Oil Company, operating in the Gulf of Mexico, released an official statement. They confirmed the video was real and had been recorded by their Perdido drilling platform on the morning of November 11, 2007. At the time, the platform was drilling for oil at a depth of 8,200 feet when it accidentally captured this footage of the alien squid. Shell also released full photographs of the creature. The tentacles were reported to be 20 times the length of its body. Based on the lighting and spatial references, experts estimated the creature's total length to exceed about 65 feet. What's more, the squid's body seemed to display a human-like face, almost as if it were watching us. But what exactly was this squid? To find the answer, scientists decided to go back 22 years earlier to unravel another unresolved mystery. The year was 2000. A Japanese scientific expedition team was conducting research near the Mariana Trench. They lowered a deep-sea bait box to a depth of about 5,250 feet. At first, several sharks, each around 6.5 feet long, came to feed. But suddenly, all the sharks scattered and swam away. Then, a massive shadow approached, stirring up clouds of sediment that blocked the camera's view. Once the water cleared, marine biologists finally got a look at the creature's face. It was a shark. Given that the bait box was approximately about 10 feet wide, the shark was estimated to be at least nearly 60 feet long. Could it have been a Pacific sleeper shark? That seemed unlikely, as the largest known Pacific sleeper sharks only reach about 23 feet. Even their Arctic relatives, the Greenland sharks, can live for 400 to 500 years, yet only grow to around 26 feet. So why was there such a massive sleeper shark in the deep sea? Scientists proposed a theory known as deep-sea gigantism to explain this mystery, an idea supported by historical reports of giant sea creatures washing ashore even before the age of advanced underwater exploration. Some examples include oarfish stretching up to about 23 feet, spider crabs growing over around 13 feet across, hooked shrimp as large as a human palm, grouper fish so massive they could fill an entire swimming pool. These are all species affected by deep-sea gigantism, much larger than their shallow water relatives. So why does deep-sea gigantism occur? 1. Low temperatures. The deep ocean is extremely cold. To conserve heat, organisms may evolve larger bodies. Larger animals have a smaller surface area to volume ratio, which slows down heat loss. This principle applies on land, too. Humans and animals living in cold climates tend to be larger, while those in tropical regions are often smaller to better dissipate heat. 2. Food scarcity in the deep sea. In such nutrient-poor environments, being big can help animals store more energy. One remarkable case involved a giant isopod, specifically Bathynomus giganteus, captured by Japanese researchers and placed in an aquarium. It survived for 5 years without eating or drinking before it finally died of starvation. This endurance reflects the deep-sea lifestyle, where animals might go years without food. As the saying goes, 3 years without business, and once it opens, it lasts for 3 more. In other words, deep-sea creatures must be built to survive long stretches of scarcity. Number 3. High oxygen levels due to pressure. Another factor involves dissolved oxygen. Back in prehistoric times, Earth's atmosphere had much higher oxygen levels, which likely contributed to the enormous size of insects and dinosaurs. Similarly, in the deep sea, high pressure increases the amount of oxygen dissolved in water, which could enable marine organisms to grow much larger than their shallow water counterparts. And sure enough, in 2018, a research team encountered the same type of giant sleeper shark once again. The massive creature easily devoured the bait intended for a submarine and then swam directly across the top of the sub, truly resembling a giant sea monster. With that chilling discovery, scientists resumed their investigation into the original alien squid. Could it also be a case of deep-sea gigantism? Could there be a second specimen waiting to be discovered in the icy depths of Antarctica? In 2015, researchers identified a remote sea region near Antarctica for further exploration. After 2 years of persistent searching in 2017, they finally captured a clearer image of the alien squid. But upon seeing the footage, how did you feel? Was that truly the same creature from 2007? Something felt off. The signature 90-degree bent tentacles from the 2007 video were nowhere to be seen, and the size didn't match the original estimates. Scientists soon offered an explanation. The squid captured in 2017 was likely a juvenile. Its species is known as the Magnapinna squid, also called the bigfin squid. Human understanding of this bizarre deep-sea species is still extremely limited. Its long, string-like tentacles, some of which can stretch up to 20 times the length of its body, might be used to collect food from the ocean floor or snatch drifting plankton from the water column. As of now, humans have only encountered the Magnapinna squid, this alien-like deep-sea creature, 7 times. 1988, filmed by the French research vessel Nautil off the northern coast of Brazil. 1998, recorded by Japan's Shinkai vessel in the Indian Ocean, south of Mauritius. 3 and 4. 2000, 2 separate sightings in the Gulf of Mexico. 2001, filmed from above, offering a rare top-down perspective. 2017, the juvenile specimen was captured in Antarctic waters. 2021, a remarkably clear video captured the squid once again, this time purely by chance. In all of these images and videos, the creatures share the same eerie features. Their enormous size, the long, thread-like tentacles, and an overall appearance that closely resembles the original alien squid sighting from 2007. And their massive proportions, perfectly in line with the concept of deep-sea gigantism. So, does that mean the mystery has been solved? Not quite, because deep-sea gigantism is still just a hypothesis. From a scientific standpoint, to elevate this idea into an accepted theory, we need more evidence. Specifically, more species that display the same gigantism traits in extreme deep-sea environments. That's why, in recent years, scientists have been flocking to Antarctica, one of the last unexplored frontiers on Earth, believing that even more astonishing discoveries are waiting to be found beneath its icy waters. In fact, in 2017, a journalist embedded with a full-scale expedition to Antarctica, documenting everything. The expedition began from Tierra del Fuego, the southernmost point of the world. 3 days later, the vast expanse of the Antarctic continent appeared before them. It was a land completely covered by glaciers. In some places, the ice sheet reaches over 15,700 feet thick, and the average thickness is around 7,875 feet. These glaciers contain 70% of the world's freshwater supply. If all of them were to melt, global sea levels would rise by about 197 feet. Currently, the entire glacier mass presses down on the Antarctic landmass, causing the continent itself to sink under the enormous weight. This is one of the key reasons why the deep sea around Antarctica is so unique. Near the continental shelf, the coastal waters already reach depths of 1,640 feet, while beyond the shelf, the steep cliffs and abyssal plains can easily descend to depths of over 13,100 feet. Once the research vessel reached the target area, the team began diving. At 49 feet, they observed an iceberg's strange, pitted surface with indentations reaching the seafloor. Sensors showed seawater temperatures at 28.8 degrees Celsius, below the normal freezing point, but the high salinity prevented the water from freezing. At 164 feet, they reached the iceberg's base, still no signs of life. Diving deeper to 1,640 feet, the water temperature was 29.8 degrees Celsius. Upon turning on floodlights at the Antarctic continental shelf seafloor, they were astonished. The area was teeming with life. Normally, without sunlight, seafloors at this depth are barren, but Antarctica proved the opposite. The creatures there were extremely primitive, and at first glance, they looked like tangled seaweed. However, they were actually animals, surviving by filtering nutrients from seawater. There were orange soft corals, as well as simultaneous hermaphrodites like sea squirts that eat their own brains after birth. There were also sea lilies, whose special skill is their ability to swim gracefully like flowers drifting through the ocean. What they saw at the time, though, was the sea lilies in their stationary, rock-clinging form. Then another pink creature appeared on the seafloor. These were known as sea pigs. Their ability? They walk using numerous small legs, while rhythmically feeding themselves with debris they collect from the seafloor, placing it directly into their mouths with a steady rhythm. Next came a sighting of the legendary deep-sea tripod fish. This species stands upright on two legs planted into the seabed. Another similar species is the deep-sea tripod spiderfish, which has 3 legs, with the longest reaching up to 3 times the length of its body. When standing, these legs are extremely rigid, but when swimming they become remarkably flexible. And this makes you think, doesn't it? Doesn't it remind you of the alien squid we saw earlier? Perhaps the icefish, tripod fish, and Magnapinna squid all share a unique deep-sea adaptation embedded in their tentacles. But what exactly is this adaptation? That is the very question scientists are currently researching. Some of the small hornless fish seen in the area were also icefish. Their bodies were completely transparent, which meant their blood was also transparent. Why would blood become transparent? It turns out the oxygen concentration in these Antarctic waters is so high that the fish no longer need hemoglobin to transport oxygen. They can absorb enough oxygen directly through their blood plasma. This suggests that the long-anticipated deep-sea giant may be about to appear. At 1,800 feet, they spotted a giant starfish measuring around 16 inches across, far larger than the usual 4 inches. Next, near the cliffs of the oceanic abyss, stood a giant sponge roughly 3.3 feet tall, in stark contrast to the fist-sized sponges typically found in shallower waters. Descending further, the expert explained that alongside cold temperatures, food scarcity, and high oxygen levels, Antarctic waters also benefit from a fourth factor: island gigantism. There's one theory that when species evolve in isolation on an island, they tend to grow larger than their mainland relatives. Examples include the Komodo dragon, the Galapagos tortoise, and the now extinct New Zealand moa, all results of island gigantism. In fact, the Antarctic Ocean is also considered an isolated ecosystem, gradually forming over the past 100 million years. Surrounding it is the Antarctic circumpolar current, which effectively cuts off warm currents from the equator, causing Antarctic waters and climate to remain extremely cold. Before becoming an isolated, icy landmass, Antarctica was once a tropical rainforest, even home to dinosaurs. Beneath the Antarctic ice sheet, scientists have even uncovered prehistoric tropical plant remains and fossils of massive dinosaurs. Descending to 2,130 feet, 4 ribbon-like shapes appeared, revealing a giant jellyfish over 33 feet long, the legendary Stygiomedusa gigantea, also known as the Hell's Gate jellyfish. Seen fewer than 120 times, it remains largely mysterious. Its silky, flowing limbs gently sway in the water, forming a drifting net to capture plankton and small marine life. The dive continued, down to 2,300 feet. What would they encounter next? At that moment, the scientists extended a juvenile Antarctic toothfish from the submersible's robotic arm. They hoped it would lure out the giant squid, perhaps even the legendary Kraken. In ancient tales, the Kraken was a gigantic sea monster with tentacles said to rip apart ships and devour sailors. For the longest time, scientists believed the Kraken was purely mythical. However, with continued research, they began to suspect that the Kraken's true inspiration might actually be the giant squid. The first scientific record of a giant squid appeared in 1877, when a specimen measuring about 66 feet long was reported in São Paulo, Brazil. Unfortunately, it decomposed quickly and no physical specimen was preserved, only a drawing from the scene was left behind. But beyond formal scientific circles, around the same time, in 1873, an American pastor displayed a giant squid limb in his own bathtub and even took a photograph of it, one of the earliest visual records of the creature. Fast forward to 2004, a complete giant squid was unexpectedly discovered in the waters off Japan. After careful research, scientists confirmed this was indeed the giant squid. Later, scientists found fragments of a giant squid's limbs inside the stomach of a sperm whale. Based on size estimates, this particular squid was likely 49 to 59 feet long. Then, in 2006, someone claimed to have captured footage of a giant squid in the wild. A deep-sea photographer named Scott was researching the Humboldt squid at the time. He attached a camera to the squid's mantle fin and released it back into the ocean. As the squid descended, the camera kept recording. At a depth of 1,150 feet, a giant squid suddenly appeared on the footage. Its tentacles reached directly toward the camera, and by visual estimate, it was over 33 feet long. Even more astonishing, it seemed to intentionally attack the camera. It appeared as though it was trying to help the injured Humboldt squid remove the foreign object from its body. This behavior suggested the giant squid might possess curiosity and even empathy, hinting at a highly intelligent species. Then finally, in 2012, a Japanese team successfully filmed a clear video of a giant squid. It was gracefully swimming at a depth of 2,070 feet, about 630 meters, and was estimated to be over 43 feet long, more than 13 meters. Its two enormous eyes looked directly at the camera, creating a truly awe-inspiring moment. Back in the present expedition, the baited toothfish was still drifting in the deep sea, while the submersible's battery was running low. It was time to begin the ascent. The lights were switched off as the submersible started rising. But just then, a nearby support sub suddenly shouted, "Something is approaching! Turn on the lights!" An estimated 400 trillion Antarctic krill inhabit the Southern Ocean, weighing over 1.1 trillion pounds, exceeding the combined biomass of all 7.7 billion humans, which totals around 770 billion pounds. By this measure, krill may be Earth's most abundant animal species. Outside, the swarm thickened dramatically, shifting from a gentle drizzle to a dense blizzard of shrimp. One scientist pointed toward a glowing spot. These shrimp are bioluminescent. They can emit light. Bioluminescence is a common trait among deep-sea creatures. Krill prefers to spawn near the surface, and each female can release tens of thousands of eggs at once. These eggs then sink rapidly to depths of nearly 9,850 feet in the Antarctic Ocean. Once hatched, the young krill rise back up to the surface to begin the cycle again. As the team discussed this, they turned off the lights. And in the pitch-black water, countless glowing blue flashes appeared around them, like stars scattered across the night sky. These krill sustain all of Antarctica and also feed the two largest animals on Earth, the blue whale and the humpback whale. Humpback whales use bubble net feeding to catch krill. They blow streams of bubbles to form a trap, herd the krill into the center, and then devour them all at once. Blue whales take it even further. They essentially farm krill, fertilizing the waters with nutrient-rich feces containing nitrogen, phosphorus, and potassium to boost krill growth, turning the ocean into a giant krill pantry. Then, with a powerful forward thrust, the whale uses its enormous mouth to swallow the entire krill field in one massive gulp. After that, the expedition crew returned to the surface. Although they didn't find any new deep-sea monsters, the scientists shared with the journalist another astonishing Antarctic discovery. They had found that beneath the Antarctic ice sheet, which stretches for thousands of feet, over 3,000 meters in some areas, there were actually more than 400 subglacial lakes. The largest of these is called Lake Vostok, located directly beneath Russia's Vostok station, an absolutely massive lake. It even has tidal activity, suggesting the potential for a fully independent ecosystem beneath the ice. And this lake? It's been sealed beneath the ice for at least 420,000 years. Remember the 4 conditions of deep-sea gigantism? Low temperatures, high oxygen levels, food scarcity, and the island effect? Lake Vostok meets all of them. That's why some scientists speculate that it might be hiding prehistoric giants from 420,000 years ago, or at least species that have evolved independently for that long. For 420,000 years, Lake Vostok has been trapped beneath about 13,100 feet of ice, with water temperatures at 26.6 degrees Fahrenheit, but still not frozen, because the immense pressure lowers the freezing point of water. That same pressure also boosts the lake's oxygen solubility, making it at least 50 times higher than that of typical lake water, up to 300 milligrams per liter. To give you an idea, the oxygen concentration in air is about 21%, which is roughly 310 milligrams per liter. This means that if a person were to fall into Lake Vostok, they wouldn't drown. The water is technically breathable as long as your lungs are strong enough to inhale liquid. Scientists also found evidence of an underground geothermal heat source in the lake, similar to deep-sea hydrothermal vents, potentially acting as the lake's sun and fueling its hidden ecosystem. If a prehistoric giant does live in Lake Vostok, what might it eat? Just as phytoplankton feed krill, which in turn feed blue whales, this heat source could support halophilic shrimp, commonly known as brine shrimp. These shrimp survive by absorbing chemical energy from geothermal activity and reproduce rapidly, generating new offspring in just 9 days through parthenogenesis, reproduction without mating. Why brine shrimp? Because they resemble shrimp and thrive in brine, salty, mineral-rich water similar to cooking brine. In Lake Vostok, these shrimp could feed on geothermal brine, multiply quickly, and sustain deep-sea giants, just like krill nourish whales. Let's continue with the story of Lake Vostok exploration. Back in the 1960s, Soviet scientists were the first to identify Lake Vostok. You didn't need fancy technology. Satellite imagery clearly showed a flat, uniform surface, sharply contrasting with the surrounding terrain, revealing the presence of a lake hidden beneath the ice. The Soviet team then established Vostok Station on the site and began drilling. In the 1970s, they drilled to a depth of 3,125 feet. In the 1980s, they reached 7,225 feet. By 1996, with a new drill, they pushed the depth to 11,890 feet. At that point, they encountered a layer of subglacial ice, known as accretion ice, that hadn't completely frozen solid. Inside it, they found DNA from ancient bacteria. Then, in 1999, they drilled another 328 feet deeper, coming within just a few dozen feet of the lake's surface. But suddenly, the Russian scientists halted all drilling. They poured about 132,000 pounds of kerosene into the borehole to prevent refreezing, then sealed it off completely. Why? Did they discover a prehistoric monster? Or were they worried about ancient pathogens escaping? Later, the Russians explained that they were concerned microbes on the drill bit might contaminate the lake's pristine environment. They planned to wait for the right time and use a new heat drilling system designed to prevent contamination to pierce the final 164 feet of ice. They also anticipated that, with so much dissolved oxygen, the lake could erupt like a shaken soda bottle under pressure. So they continued refining their methods for over a decade. Finally, in 2012, during what some feared might be the end of the world, the Russians resumed drilling. They broke through the final layer of ice, and just as predicted, the lake water erupted, shooting hundreds of feet into the air due to the enormous pressure. The world didn't hear about this until 2015. What exactly happened at that moment? We still don't know for sure. The Russian team only reported that, after analyzing the expelled water, they discovered 3,507 distinct genetic sequences. Of these, 94% were bacterial and 6% belonged to complex organisms. The findings suggested that Lake Vostok has a complete and complex ecosystem, including bacteria, fungi, protists, and even soft-bodied animals. Among all the DNA sequences, 2 were completely unknown to science. What were these 2 mysterious species? We don't know. Since then, the Russian scientists permanently sealed off the borehole with no further plans for exploration. Meanwhile, American and British scientists have also drilled into other subglacial Antarctic lakes. The US lake lies about 2,625 feet beneath the ice, 800 meters, and is quite small, only about 6.5 feet deep, 2 meters. The UK lake lies at a depth of 11,150 feet, about 3,400 meters, and is more similar in scale to Lake Vostok. In 2015, the US team successfully drilled into their smaller lake. They sent down a robotic submersible, which filmed dozens of small fish and even brought back a bright red, bizarre-looking shrimp. Their discovery confirmed one thing. Even though these Antarctic subglacial lakes have been sealed off for hundreds of thousands of years, independent ecosystems do indeed exist beneath the ice. That means the theories about Lake Vostok, of heat sources, brine shrimp, hidden ecosystems, and unknown species, could all be true. And just maybe a prehistoric deep-sea giant from 420,000 years ago is still lurking in the darkness of Lake Vostok. What really lies beneath the sea? That's the end of today's story. Thank you for watching.